This video is on finding where the function is increasing and where the function is decreasing. So we have for this question here, for what values of x is the function y equals x squared minus 6x plus 11 increasing? And then for what values is it decreasing? Now here I've got a sketch of the graph. Now this question is really something that you need to be able to answer without sketching the graph. Okay, so I just have the graph here just to illustrate what we mean by an increasing and a decreasing function. So we can see that this part of the graph, the gradient is positive all the way up to this point here. So all of this part of the graph, the function is actually increasing. Okay, so as I go up in x, the values are going up there as well. Now here, this part of the graph, the function is decreasing because as I go up in x, the values here are actually decreasing. So as I go up in x, I'm actually coming down. So here I can actually clearly see where the function is increasing and where it is decreasing. Now, how would we do this if we didn't have this diagram? So what we can say is here the function is increasing, and I did mention that the gradient here is positive, and here the function is decreasing, so the gradient here is negative. Okay, so we're looking for the gradient to be positive where the function is increasing, and if we find where the gradient is negative, we know that that's where the function is decreasing. So let's find the gradient function of this. So y equals x squared minus 6x plus 11. So I'll start by writing that. So for part A, I have y equals x squared minus 6x plus 11. Okay, so the gradient function would be dy over dx. So I have to differentiate that. That's going to be 2x minus 6. Okay, so I need to find where this, my gradient, is going to be positive. So positive can also mean more than 0. So I can say, okay, so where is 2x minus 6 more than 0? Okay, so I can just solve that. So I have a linear inequality here. I can just solve that. So I can have 2x is more than 6. So x must be more than 3. So whenever x is more than 3, my gradient is going to be positive, and that is where the function is increasing. And I can see that from here. So when x is 3, we're here. When x is more than 3, this function is increasing. Okay, so it's quite clear where it's decreasing as well. But let's use that similar method, okay, to find where it's decreasing. So I've already got the gradient function dy over dx, so I'm going to start by writing that. So I've got that b, so I have dy over dx, and I have 2x minus 6, so that's equal to 2x minus 6. Okay, so where is it decreasing? So it's decreasing when the gradient is negative, or I can say less than 0. Okay, so I can say 2x minus 6 is less than 0. Okay, so now I can solve this. So 2x is less than 6, and then I have x is less than 3. So when I have x values that are less than 3, the gradient is decreasing. So I can go anywhere here where x is less than 3. I will always find myself in a position where the gradient is negative and the function is decreasing here. Okay, so here are some questions for you to try. So here you need to find where these functions are increasing. Here you need to find where these functions are decreasing. Okay, now this is a fairly challenging question, okay, but I think everyone can do this. Okay, and here you need to say for what values of x are the two functions above, so these two functions, neither increasing or decreasing. Okay, so for what values of x are these functions neither increasing or decreasing? So answer these questions and then bring that to the lesson.